Lesson 12.7, motion problems with trig level 1. You might want to pull out your unit circles for this if you don't have some of these trig values memorized. And the only two trig antiderivatives we're going to focus on are sine and cosine. And so we just kind of have to think backwards in our brain of what was the derivative of sine, what was the derivative of cosine. Well, remember, derivative of sine is simply cosine, but the derivative of cosine is negative sine. So the antiderivative of sine, if I say that's cosine, you got to think then if I took the derivative of cosine, that's negative sine. So to make up for that negative, we actually have to say it's a negative cosine. So I almost every time have to ask myself, is the derivative of cosine sine? No, it's negative, so I have to tag on a negative. The antiderivative of cosine is simply sine, because if I were to take the derivative of sine, it is just a normal cosine. Number 1 says a particle moves along the x-axis with a velocity given by this function for times greater than or equal to 0. If the particle is at position x is 7 at a time of 3, what is the position of the particle at time is 1? So this is exactly what we did on the last lesson, just adding the trig values in there to make it a little more time consuming. Okay, so we want to go from velocity to position. So I'm going to do x of t. Remember, that is really just taking the antiderivative of our velocity function with respect to time. And that velocity function is our 3 pi sine of pi over 3t. So when I antiderive that, I'm going to keep the 3 pi in front. So the antiderivative of sine, well, I always know it's the opposite one, so it's cosine. And I ask myself, what's the derivative of cosine? Negative sine. So I would have to make that a negative. I'm actually going to float it in the front. And then I'm going to keep the pi over 3t. But remember, when we take the derivative, we have to do the chain rule and multiply by the derivative of the inside function. Well, now the antiderivative tells us to divide by the derivative of the inner. So we're going to divide by pi over 3, or really multiply by 3 over pi. And then don't forget your plus c. So then I have the pi's canceling out. So I get 3 times negative 3 is negative 9 cosine of pi over 3t plus c. And remember, this is really my position function. I have to figure out what c is, and I go back to what it tells me is an ordered pair. When the time is 3, I know the function is at a position of 7. So I'm going to say 7 equals negative 9 cosine of pi over 3 times a time of 3 plus c. 3's are going to cross cancel. So I'm left with just cosine of pi. I have to figure out what cosine of pi is. So remember, on your unit circle, pi, this is 0, pi is 180, so it's over here. Cosine is the x. That is not a very good circle, sorry. Cosine is the x value. So all I have to think of is, what is the x value at this ordered pair? It goes negative 1, comma 0. The x value is negative 1 because it went left 1. You could also come over here and look at your unit circle. Here's pi. We would want the x value, which is negative 1. So I'm going to say it's negative 9 times, because that's what that's saying, times what is cosine of pi, which is negative 1, plus c. That multiplies to make positive 9. Subtract 9 from 7. C is actually negative 2. All right, so I'm going to come over here. I'm going to write my position function again, which is negative 9 cosine pi over 3 times t, and then really minus 2 for my c value. Now I want to find when the time is 1. I'm going to do x of 1 equals negative 9 times cosine. Pi over 3 times 1 is still pi over 3 minus 2. What I like to think of is, since pi is 180 degrees, what is 180 degrees divided by 3? That's a 60, right? So I'm thinking of cosine at a 60-degree angle. I don't know if you remember this, but 60 degrees, this should be my 30. this adjacent side should be a 1/2. And since it's pi over 3, that's the 60, which is in quadrant 1, it'll be positive. So this should be -9 times 1/2 minus 2. But if you don't know that, use your unit circle, find pi over 3, which is right here. See the x value is 1/2. It's saying what is the adjacent leg here? It's a shorter leg in a 30, 60, 90. So that would be -9/2 minus 2, which is -9/2 minus 4/2, which is -13/2. Or you could say that's -6.5. That's your answer. All right, let's try another one. Particles moving along the x-axis with this given velocity. Now we have cosine in it for times greater than or equal to 0. The particle is at a position of 2 when the time is 0. What is the position of the particle at time of 8/3? So let's go ahead and find the antiderivative of 5 pi cosine pi over 2t with respect to time. So again, I'm going to keep the 5 pi. I'm going to think, okay, antiderivative cosine, sine. So if I were to derive sine, that is cosine. So I don't need a negative or anything like that. Then keep your inside function the same, but then we're doing the opposite of deriving, so we want to divide by pi over 2, or really multiply by 2 over pi. And don't forget the plus c. Pi's will cancel. 2 times 5 is 10, times sine pi over 2t plus c. That's my position function. Use your ordered pair. That position of 2 when the time is 0. I like having 0 in there. So I would replace this with 2. 10 times sine of pi over 2 times 0 is just 0. But don't assume this is 0. Sine of 0. That is when it's 0 degrees. That's right here. Or 0 pi. We want the y value. So that ordered pair would be 1, 0. It has a height of 0, or y value of 0. So yeah, that is actually 0. 10 times 0 plus c equals 2. Well, that's 0, so c equals 2. That means my position function is 10 times sine of pi over 2 t plus 2. And then I want to find when it is a time of 8/3. All right, we're going to cross simplify our 2 and our 8, so divide by 2. That would be 4 pi over 3. Okay, 4/3. 4/3 of a pi. I know that that's actually going to be a whole pi, 3/3, and then 1/3 more. So I'm trying to figure out what is the y value of that point. Since I'm thirds, 180 divided by 3, that's my 60s. So I'm trying to find sine of a 60, which would be the longer side. That's a square root of 3 over 2, because this is the short side, or leg is a half. So I want square root of 3 over 2, and since I'm here though, my y value is going to be negative. So I'd have 10 times negative square root of 3 over 2 plus 2. If you don't understand that, go to your unit circle. Here is the 4 pi over 3, because it's literally 1 pi plus 1/3 more, or another 60 degrees. We want the y value, which is right there. I'm going to cross simplify my 2 and my 10. So I get -5 square roots of 3 plus 2. I would not do any more because it didn't say it around. This would be our precise answer.